Alright, so we're going to be looking at exponential and logarithmic functions right through the material for this test. And it can get quite involved, so we're just going to have some basic, one basic thing in this video. So an exponential function or an exponential expression is one that has an exponent in it. So x equals a to the y. This would be called an exponential form, and the a here is called the base. And then we have a logarithmic equation here, and this is the logarithm of x taken at base a is equal to y. And so what we have here is two different forms of the same thing. So this double-headed arrow means is exactly the same as. That's what that double-headed arrow means. So I'm going to rewrite it down here. Now we want our base not to be equal to 1, and we want our base to be positive. So this is a conversion of how we get from exponential form to logarithmic form, or if we start with logarithmic form and we get to exponential form. Okay, so solve this. We want to get what x is, and so what we'll do, and you'll have to know this, is you identify, okay, this is in logarithmic form. That's going to be my a, that's my x, and that's my y. Now that is the exact same thing as this, so I'm going to write it in my different color. And then let's get back to the original black of this. So the red x happens to be the black x here. The red a is 4, and the red y is 5/2. So this is what x is equal to exactly. And it might be a nice number, it might not be, but we can do 4 to the power of 5/2 and 32. So I have solved that by doing the conversion. I've solved it for x. Solve this one. That is a logarithmic formula, and we can do a conversion to exponential formula to solve it. Now we're going to have to identify the a, the x, and the y. So this is why we need the different colors. So this one, the x's are mixed up before they aligned. So this will be our x, that will be our y, and when that's labeled like that, then I can write it like this. And now go back to the original color. The red x is 8/27. The red a is x, and the red y is cubed. We've been told to solve for x, not x cubed. So what is x? Well, to get x cubed, I either need to take everything to the 1/3 power or take the cubed root of both sides. So if I take the cubed root of both sides, these three undo each other, and I'll just have x. And here, that's the cubed root of 8 over the cubed root of 27. The cubed root of 8 is 2, and the cubed root of 27 is 3. So I have solved this. X is 2/3. And finally, what about this one? Solve that. So again, I have a logarithmic form. So that's going to be my a, that's going to be my x, that's going to be my y. And I can go to exponential form, and then back to the original color. So the red x is the cubed root of 7, the red a is 49, and the red y is the black x. Now I need to find out what the black x is. Okay, there's a nice property called the uniqueness property. So if you have a to the u equals a to the v, then you can conclude that u is equal to v. So if you have the same base, then you must have the same exponents. I'm going to write that as 7 to the 1/3. 49 I'm going to rewrite as 7 squared. Then what do the exponent rules say? We have to multiply. And so now I can use a uniqueness property. I have the same base. I don't have any parentheses. So the exponents have to be the same. And how do I get x by itself? I multiply both sides by a half. And so x is equal to 1/6. And that ends this video.